Objective of this presentation is to basically discuss some kind of what we call circular economy approach in practices. And while I'm making the presentation, I would like also to associate and thank all the partners from WP4 who were involved in this task. So we've been discussing regulation and already a bit of practice this morning. And the idea here is to try to highlight through practical examples what it means in practice, to apply circular economy to the commissioning of nuclear facilities and radioactive waste and materials management. So just a little bit step back to the presentation of Federica. I think it's worth it to remind the general definition of circular economy from a European perspective. The overall objective of the European Union transition from linear economy, make use, dispose to circular economy regenerative growth model is to try to contribute to reducing the pressure on natural resources, which is pretty much important, while obviously creating sustainable growth and jobs. This means that in practice, in a circular economy, the value of products, materials, and resources is maintained for as long as possible, and which is very important, the generation of waste is minimized. So the objective of this presentation, as I mentioned already, is to try to share practice, information, and lessons learned from practical case studies. And basically, all this work is based on Harper's WP4 Task 2.B. And her method between the different partners who were involved was basically pretty classical, I would say. We review the literature. We have a number of technical meeting and discussion within the partners to first present different case studies and try to highlight the lessons learned. We try to identify the good practice. And then we have online workshop in order to present our work and to dialogue with stakeholders outside the Harper's consortium, and we try to provide lessons learned. So I will not go into details of the different case studies because first, I don't have the time, and second, I'm not the owner of the case study and I don't know them by heart. But you will find more details in the deliverable 4.2 of the Harper's project, and this is downloadable on the website. And thank you very much, Federica, for the link. So basically, as already highlighted, we discuss 6 different case studies from 6 different countries, which means 6 different regulatory framework. The first one is about the repurposing and refurbishing of buildings. It was presented by our colleagues from Sogin in Italy. Then we discuss the TROS site and state and this is from UK. We discuss the recycling of concrete in the framework of conditional clearance, and that was from our colleagues from Belgium. We discuss the evolution of the national scheme for very low-level waste management in France. We also discussed treatment and recycling of contaminated steel in Sweden. And finally, our colleagues from Czech Republic highlight us with the release of small amount of minor waste. So I'm going to review, I have 2 or 3 slides per case studies. I'm going to review all of them, and then I will try to highlight some of the main lessons learned from the perspective of circular economy. So first case study was about the repurposing and refurbishing on existing building in Italy, and I will speak under the control of Federica and her colleagues from Sogin. The keywords here are regulation, refurbishment and reuse, waste storage, and environmental impact. So this case study deals with a research center, an R&D center located in Casacchia, I think 50 kilometers far from Rome. And 2 nuclear facilities were built and operated or not on this site, and the ownership of these facilities were transferred to Sogin for decommissioning purpose. the nuclear facilities as the IPU plant and the OPEC plants. And an important aspect there with regards to national context in Italy that there is no radioactive waste disposal facility in operation in Italy. So the approach of Sogin relied on its development of an integrated waste management strategy. And when I'm speaking about integrated strategy, it means that I'm speaking about radioactive, but also non-radioactive waste. And the purpose of the strategy was really to maximize the use of available treatment and storage facilities and to consider on-site temporary storage for low-level waste as well as intermediate level waste. And so a decision was made when developing this strategy to reuse an existing building of the site, which is OPEC 2, I think, building, in order to temporarily store legacy as well as other radioactive waste that will be produced during the decommissioning activities on the center. So OPEC 2 building was repurposed by Sogin into a temporary storage facility. I think that's something which is interesting in this case study, that the focus was not only on radioactive materials, and there was a general approach in order to analyze all the materials and equipment in this building, even if it was not contaminated, in order to assess the potential for reuse and recycling in order to minimize the volume of waste. So the idea was not to remove everything and rebuild everything inside. It was to use as far as possible what was inside the building. And sustainability and circular economy aspect were considered at the design stage. So highly reliable components was used, and the idea there was to minimize maintenance. And minimize maintenance, it's minimize the amount of waste produced during operation, but also the exposure of workers involved in maintenance activities. Energy efficient components we use, and the idea there is to reduce energy consumption, obviously. Specific surface coating materials were used in order to facilitate the decontamination and future reuse of the building. And also, which is what is interesting and not so much related, to breakwares and radioactivity, that material suppliers and landfill were selected in the local area in order to minimize transport and, for instance, in order to minimize emission of gas. So how it works is that there have been some preliminary dismantling activities with the removal of some components from the building, and it all started in 2008. Then the actual works to turn the building into a storage facility started in 2013. It ended in 2017. And finally, in 2018, the Italian Safety Authority issued a license for the operation of this new storage facility. What's also interesting is that this was a first-of-a-kind operation in Italy, and all the feedback experience from the Casacchia cases was used in order to provide and issue new technical guidance in order to define technical criteria to be implemented for design, construction, operation, and adaptation of existing building into temporary storage facility to ensure radioactive waste is safely stored. So it's interesting because it's not only a top to the bottom approach, but also bottom up approach there. So if we move to the next, the TROS site in Wales in UK, this case study focuses on the definition of the end states of this site after the decommissioning of nuclear facilities. Keyword there are regulation, waste hierarchy, multi-criteria analysis, and the value framework and stakeholders engagement. So the TROS site in UK is managed and operated by Nuclear Restoration Services, and within the site there are two Magnox reactors, which were shut down in 1991, and since 1995 the site decommissioning program is underway. Subjective, obviously, of the program is to enable a release of the site from nuclear regulatory control. So what is interesting there with regards to the regulatory framework in the UK is that it is mandatory to implement the waste management hierarchy. So I put an NDA waste management hierarchy, but waste management hierarchy is some more general concept that may be found in a technical document from EIEA and so on. And there is on the right of the slides a very schematic view of what is a waste hierarchy approach. It lists the different options for the management of radioactive waste and materials, from the preferred options, which is waste prevention, up to the least preferred option, which is a disposal of waste. And waste management hierarchy is really part of circular economy principle in general. So what is interesting in TrustSite also, in addition to this approach for the waste management, is the use of the NDA value framework. This document can be downloaded on the website of the NDA, which is Nuclear Decommissioning Authority of the UK. And the idea of this framework is when making decision, the idea is really to consider all the impact of the decision: environmental impact, economic impact, as well as social impact. And you can see here on this scheme what are the different type of indicators which are going to be considered when making a decision. And all these aspects are taken into account while defining the best possible strategy for the end state definition. So here, for instance, what you can see in the case of the TrustSite dialogue on the end state is that you have a number of, I'm sorry if it is difficult to read, but you have a number of attributes which are considered, and you have 1, 2, 3 options which are assessed with the first one on column 2, which is the removal of all radioactive materials and disposal of all this radioactive material off-site. And in the fourth column, for instance, you have the pure in situ disposal. And the idea there is not, to provide detailed numbers, but to assess relative benefit of an options against the other. And this type of scheme is really interesting when you go for stakeholders, local stakeholders discussion to see what are the benefit of an option compared to another. And with regards to the attributes which are considered, you can see that it can be about occupational exposure, for instance. It can be also about the cost. It can be also about the memory and so on. So it's really a useful tool to assess benefits and of different options in relation to another, obviously. So what was this comparison different option allows to discuss new type of options. Decades ago, the only options which was available was to send to the disposal all the radioactive waste and materials. With a change in the UK regulation since 2018, it is possible to consider also in situ disposal of radioactive materials as a possible options. And finally, within the discussion with stakeholders, it was recognized, I would say, that an hybrid scenario with in situ and off-site disposal was pretty much interesting for with regards to different parameters, and offers result, I would say, in significant benefits with regards to circular economy. It allows to avoid the consignment of significant amount of waste to the disposal because there is a light low-level waste repository in the UK, but this repository have only limited capacity. And if you want more capacity, it requires also resource to develop new repository capacity. So it's really interesting to compare different type of scenario and to consider this in situ disposal a possible options, specifically because, for instance, some radioactive materials can be used on site as a bulk void filling materials. So now if we move to Belgium, in Belgium with our colleagues, we discussed the possibility of concrete recycling in the framework of conditional clearance. And this echo the second presentation we have this morning from our colleagues from Bellevue. So key words there: recycling, conditional clearance, concrete regulation, and conventional industry. So it is not a surprise that when you go for the decommissioning of nuclear facilities, you are going to generate huge quantity of concrete with different level of radioactivity. And that case study focused not on the concrete, which could be cleared under the unconditional clearance level. It does not consider the concrete, which would be considered as radioactive waste. It does focus on the concrete with level of activities which was higher than unconditional clearance. And with the idea of really focus on that one and to try to assess different options for reuse this concrete and not to send it to either conventional or radioactive waste storage facility. So what is interesting in this case is that there is really a desire to get some lessons from good practices outside the nuclear industry. I would say that all these sustainability assessments, circular economy approach, and so on, there is nothing new there, and there is probably very good lessons for the nuclear industry to be taken from the conventional industry. And here you can have what you can see on the scheme is that there is comparison at maybe some high level about cost optimization, sustainability approach, and also space, use space. And you see that one very promising option would be to reuse some concrete somehow in order not to have it stored, but for instance, to feed low carbon concrete initiative. So all this rely, and this was discussed already in the presentation 2 and 3 we had this morning, on demonstrating that individual doses associated with the practice, recycling, reuse, or whatever, are below 10 microsievert per year. And this is in the Belgium Royal Decree 27/2001, as we thought this morning on already. I think it's really important to focus really on those criteria rather than a set of clearance levels and numbers, because it provides probably more flexibility in the application of clearance in the field of nuclear industry, and it allows to explore alternative scenarios which are based first on a good understanding of the different steps in recycling of concrete. So what could be the exposure of workers involved in crushing, mining, and so on. It allows to define key exposure scenarios based on actual practices and to ensure that exposure kept below, let's say, 10 microsievert per year. As a whole, our partners from Belgium highlight the fact that there is really value to be associated with engaging with conventional industry. So if we come in France now, keywords of this case study. So again, it's about regulation, obviously, recycling, reuse, stakeholders engagement, and R&D. So it was also highlighted this morning in the presentation of a colleague from Bellevue that up to recently, at least, the management of very low-level waste in France was based on disposal as the only option. And there's a disposal facility in France called CIRES for this type of waste, which is a centralized one. CIRES was designed to receive 650,000 cubic meters of very low-level waste, but obviously, this is not sufficient because the decommissioning of nuclear fleet and other nuclear facilities will generate more than 2 million cubic meters of very low-level waste. So there is really a need to review this strategy and try to assess the feasibility of alternative options. And this will take place, and it was actually based on 4 pillars. The first one is to have detailed knowledge of what you have as very low level waste, and it's not only about the subacqueous concentration, but also the physical type of material that you have. Secondly, reduce the volume of waste as far as feasible to be produced and disposed of. And this is in line with, the first principle of the waste management hierarchy, which is about preventing the production of waste, promote circular economy approach and sustainable development approach, and trying to anticipate the need for disposal capacities. That one is really important because if you generate waste that you are not able to deal with, then you cannot decommission nuclear facilities. So finally, what are the outcomes of these reflections? And stakeholders, outside of, nuclear industry, WMOs or TSOs were associated with, this work. What is important is to manage disposal space as a resource, and this is in line with what we saw in UK for TROS. The space for radioactive waste storage is limited and it's valuable. There is a need for regulatory evolution, obviously, and it was mentioned this morning that there were 2 decrees in 2022 allowing for the recycling of metallic materials only. There was also R&D project which were on in order to recycle copper in electric cables, which is very important because first, copper is really expensive, and there is a lot of electric cables in nuclear facilities and especially nuclear reactors. Concrete fragmentation and crushing in order to, use crushed concrete for backfill materials was also investigated through adequate R&D activities. And finally, increase of disposal capacities was also investigated, and the disposal capacity of CERES will increase from 650,000 cubic meter to something like 900 cubic meters. But anyway, this will be not sufficient to face more than 2 million very low level waste to be produced in the future. So this is a scheme basically of what we have before and what we have after. And what is important, I would say there is that the evolution of the strategy provide more options and then more strategy in order to implement, let's say, more sustainable circular economy approach and to move from a purely linear approach that we had in France, basically because everything was disposed, to something which is more circular, allowing, for instance, for the recycling of metallic very low level material. Next case study was about the treatment and recycling of contaminated steel in Sweden. So keywords: recycling, steel robustness. Recycling of steel is a well-established practice in Sweden, taking place in former Studviks and Cyclife facilities. It started in 1987, so there is a lot of knowledge there to be used for different type of stakeholders. More than 50,000 tons of metals have been melted, and 95% of these melted metals have been subject to clearance and recycling into new products outside the nuclear industry. So this is a very interesting case. And what we need also to keep in mind that practical experience show that between 5 to 10% of the total mass of a nuclear power plant consists of ferrous materials, so which could be recycled. Not all of them, of course. I'm not speaking about activity part of the vessel, for instance, but still there is a lot of materials to be recycled there. An important aspect of this case study, coming from a Swedish partner, is to ensure the trust and robustness of the process. You need not only to focus on melting, but to what's happening prior melting and what's happening after melting, and to ensure that during all the steps of the process, you apply adequate and I would say proportionate measures of relation protection as well as safety. You need to consider pre-shipment activities, shipment and arrival on site, permitting operation, melting, post-treatment activity reporting, traceability, and obviously also return of residual waste coming from the melting process. It's really important to have all these different steps in mind. And finally, this conclusion of this case study is that the melting of contaminated metals for clearance purpose brings several advantages, clearly, with regards to circular economy. It is a proven and robust method to convert a liability, let's say a waste, into an asset, some valuable material. And finally, the sixth case study coming from Czech Republic. It's interesting because it's about the releasing of small amounts of mine waste. So we are dealing with clearance, recycling, reuse, and small inventory. There are two nuclear sites and two nuclear power plants in operation in Czech Republic. So we are not talking about decommissioning. We are talking about, trying to make the best with radioactive waste and materials produced during the operation of these nuclear facilities. I'm in Temelín and Dukovany. Based on the feedback of our colleagues, 70% of the waste which are generated during operation in nuclear locales is capable of being released. To provide us with different examples, for instance, plastic. Plastic can be crushed, and they are crushed in equipment at the public municipal landfill in Petrovsky. And then they are burned. They are not stored, they are burned in a cement plant in order to produce heat. And the volume is of plastics which have been treated this way is obviously really small, 12, something like 12 cubic meters, but still it has been reused, recycled, and it also prevents some cost for storage of these materials as a radioactive waste. An interesting point also, because that's clearly an issue in some countries, what to do with oil which is contaminated at very low level. And our colleagues from Czech mentioned that this cement plant, which was burning the plastic, they also take oil free charge as a fuel, and this means 20 cubic meter of oil which are treated this way per year. With regard to the metals, metal sends some of the metal which is produced during operation. It's sent to Site Life facility in Sweden, which was just mentioned in the previous case study. And since the year 2011, close to 200 tons of metal were released and recycled this way. And this includes also copper from cables, for instance. With regards to building debris and rubbles, they are transported and characterized, and they're used as backfill materials. The issue there is the capacity which are available for the transportation, and also the cost of transportation, because basically when the distance is getting higher from the place where you produce your waste to the place where they can be characterized and then used as backfill materials, the longer the distance is, the more expensive it may cost you to send these materials for clearance. This highlights the fact that obviously, and we'll come back to it in the concluding remarks, the cost of the different options that you have is a very important aspect of decision making. So now if we move to the lessons learned, well, I'm sorry it was pretty short, but once again, we can find additional information in the deliverable from Opus, which are on the websites. So the first lessons learned is that circular economy approach for nuclear facilities, decommissioning and radioactive waste and materials management. They're well received when they are supported by open and transparent dialogues. This is what we've seen in the case of France, in the case of UK, but also in Sweden and in Italy. Also, there are already existing methods and tools which exist to discuss the benefits of such approach. And you've seen, for instance, the NDA the framework. And I think that one very important aspect is to go for really an holistic approach. It's not only about considering backwards and millisievert and so on. It's really going into indicators related to protection of the environment, conventional safety, other than ionizing radiation pollutant, and so on. So I mentioned the NDA value framework, but when it comes to conventional industry, I put there something which is also very interesting, which is about the remediation of site contaminated by chemical pollutants, for instance, and it is entitled Application in Real Environment for Contaminated Land, and it is really about sustainable remediation forum. So it's really interesting and very good lessons learned there also. There are very good experience, as highlighted by the Italian case with regards to the refurbishing and reuse of building at nuclear site. And it is clear that one of the first things that you do when you go for decommissioning is that you need to find some space for waste treatment and temporary storage. And there are a number of buildings on site that can be used for this purpose, such as turbine hall, for instance, in nuclear reactors facility. So there is good experience, but there is also ongoing R&D activity. I realized the case, for instance, in France or in Belgium, and this allow to stimulate transition from linear to more circular economy approach in the field of decommissioning and radioactive waste management. I think it is also very important when talking, about building new nuclear facility to use all this knowledge that we have for the design of new nuclear facilities in order to facilitate this type of practices in the future, but also to minimize the amount of waste to be produced and so on. I think that in all the case studies, highlighting the keywords, I use the words regulation, because we need, in most cases, evolution of regulation or development of new standards. The idea, if you want to have more options, is basically to try to be more flexible and to try maybe also in some cases to simplify the regulations, which can be pretty complicated. Lessons learned also from UK, France, and other countries with actually no disposal capacities is that radioactive waste disposal capacity must be considered and managed as a valuable and rare resources, and alternative to disposal must be explored also taking this into account. It seems pretty important to build bridge between the nuclear industry community and the conventional industry, and to benefit from the experience and to adopt also a proven solution with regards to recycling, for instance. With regards to, and we discussed a lot clearance this morning, clearance is based on 10 microsievert per year. This is a radiation protection standards, basically. Discussing during the workshop, discussing between partners, I think we already have, European directive on this. It was mentioned this morning. We have national frameworks and so on. But what could be very useful there is to develop actual tools and software and technical guidance to support development of alternative to storage options for the assessment. And with regards to existing experience in the UK, in the US, for instance, you have tools such as RESRAD. RESRAD is not only supported and recognized by the authority, but also by the different utilities and actors involved in decommissioning. And to have the same tools, it really makes a dialogue between stakeholders, I mean WMO, waste producer, the authority, but also NGOs and so on, easier. So we do believe that we may not need additional regulation, but we need actual tools and software. And if it could be supported by the European Commission, that would be very good. It was mentioned also this morning during a colleague from Bellevue presentation that there are a number of documents, very interesting and very good document by the Commission, EPRI 89 for instance, for the recycling of metals, EPRI 122 also. They could be updated and used also to develop this, tools and software. I think it would be very good to have such a tool. Finally, one of the last point is that when discussing circular economy, discussing sustainable development, where the words economy and development, which are used, and we need to keep in mind that the cost aspect is one of the most important criteria there. And as long as disposal cost will be cheaper than recycling cost, utilities, waste producers will go for the disposal. We discussed also when discussing different case of clearance that using clearance, to avoid storing your materials as radioactive waste, but at the end of the day to store it at conventional ways. So, I mean, obviously from a cost and economic perspective, it allows to save a lot of money. But with regards to circular economy and this idea of reuse, recycling, and so on, there may be no difference actually between these two schemes. So it was really interesting, for instance, to see the Italian case, which really embrace the principle of circular economy as a general driving framework to consider not only radioactive materials, but all the type of materials, and really with the idea of, minimizing the amount of radioactive as well as conventional waste. And with this, again, I want to thank all the partners of Harper's, because we discussed also within the consortium this case study, and all the owners of the different case study, and all the partners of Work Package 4.